example. This is part 2, and this is where everything sort of ended up.
Freya wanders for days, surviving on worms, river fish, and muddy water. At last, she stumbles upon a wooden Scandinavian monastery, its walls fortified with logs and surrounded by a dark moat. A towering wooden fence and door guards the entrance, as though shielding the monks from something unspeakable.
Right, so obviously she's very hungry. For those of you who remember the story yesterday, she just escaped the slave camp, right?
The monks rush to lower the portcullis and usher Freya inside. At first, they seem kind and gentle, feeding her very little even though there is lots of food, but she dares not complain. Behind their eyes, something feels wrong. That night, Freya discovers the truth when she is thrown into a cage with other captives.
All right. So don't worry, this slide looks like last week's slide, but I have changed up the values. You will notice that I just saying, if you look back in last week's notes, I changed up the hx function simply because I want you to redo this question. I want everyone to find h minus 1x. In case you can't remember, this stands for inverse. Okay, I want you all to try your best to find the inverse of h. Take a couple minutes, see. Obviously it's not an exam, you can look back how much you want, but try to produce an answer. Good luck. 2 minutes, 2 to 3 minutes. All right, so the first thing, if you look back in your notes, the first thing you want to do is replace hx. Now, I have limited space on my screen, right? So I am going, if you look at your notes, you're supposed to replace the hx with the letter y, because hx and y is almost the same thing. So I'm hoping everyone has this step, at least. You throw away the hx, you replace it with y because it's easier on your eyes. And, you just write back everything else as normal. Nothing has changed except for hx. I replace it with y. Next, you have to sprinkle the magic dust. And I had a little sound effects last week. So I'm going to put the little magic dust here. This yellow magic dust today. What does the magic dust do? Well, the magic dust switches the x and y. All the y's magically become what? X. And all the x's all magically become y. So that means this y here, he will change to x. And these two x's here will change to y in the next line. Right? How much of you had up to there at least? You made it through the sprinkling of the magic dust. Now, you got to keep in mind, this is an extension of last week's class. We're continuing. So if you're brand new to class or you missed last week and didn't go through the recording, you're obviously going to be a little tad bit lost. Great. What do we have to do now? Well, we have to make back y the subject. Remember, before we sprinkle the magic dust, who was the subject? Y. You notice y was on one side, and well, everyone else was on the other side. But after sprinkling the magic dust, who became the subject? X. Well, I think it's about time the Y's rebel and they reclaim their place as the subject of the formula. We're going to have to cross multiply. So cross multiplication is used when there's a fraction, right? We're trying to get all the y's on one side and everyone else on the other side. But this side is a fraction, but the x alone is not a fraction. But we know x is the same thing as x on 1. we're going to have to cross multiply. Now, there are two diagonals here. The blue diagonal, and I'm going to put a kind of yellowish diagonal. The truth is, it doesn't matter which diagonal you multiply first. Your answers may look different depending on which ones you cross multiply first. But believe me, mathematically, even though the answers look a little bit different, they are considered mathematically the same. Now, here's what. I want everyone to have the same working as me. I'm going to do the blue diagonal first. So if you want to have the same exact working as me, do the blue diagonal first. So everyone here gets multiplied by x, all right? So I could probably write it like this. I'll put it up here. You have x here, and I'm going to multiply the 1 minus 4y by x. I'll expand those brackets just now. And well, anything multiplied by 1 is itself. So you have 2y minus 5. So we just finished cross multiplying. Maybe I should get rid of those brackets. Everyone in this bracket gets multiplied by who waiting outside? Mr. X. X by 1 is x. And x by 4y is 4xy. Or you can put yx. It really doesn't matter. Just make sure and have the two letters here. Take down up to there if you didn't know how to reach there. Keep in mind, we're trying to make who the subject? Y. We're trying to get y alone on one side and everyone else on the other side. Oh, someone said I made a mistake. Okay, so yeah, guys, yes, I did make a small mistake. It's supposed to be positive 5 here. Not a big problem. I can fix that up right now. If it's positive 5, then here will be positive 5, and here will be positive 5. Thanks for the I don't know how I made that mistake. Great. So we're trying to get all the y's on one side and everyone else on the other side. Here's the thing. It have two types of letters here. It have x and y. Once you have a y, you belong on the left-hand side. Eh? Once you have a y, that is the rules. So this positive 2y, we need to throw him across. And this x, this positive x, he doesn't have a y, any sort of y. So we need to throw him across. So the positive 5 stay in here, and the minus 4xy stay in. Because he have a y attached to him. I know he has an x, but the point is he has a y. When you throw across the positive 2y, we get minus 2y. When we throw across the positive x, we get minus x. You can have it the other way around. Eh? You can have positive 5 and then the minus x. It really doesn't matter. We have a little problem here now. We need to isolate the y. And this is where last week I showed you how to factorize. You notice he has a y and he has a y. If you look back in your notes last week, we could extract the y by factorization. So if you pull out the y here, we have minus 2. If you pull out the y here, you have minus 4x. And this is equal to minus x plus 5. Almost finished. We want to get y alone on one side. So there's a secret multiply here. So this entire brackets, when we throw it across, you will get what? A divide. So the whole thing goes underneath. Remember, when you throw across a multiply, it goes underneath, but the signs do not change. And once you make back y the subject, you could cross out y or erase y and replace it with h inverse x. We have just found the inverse of x. Now I'm just saying, if you had cross multiplied the yellow diagonal first, I'm just saying if, although I advise you all not to do it, to have the same working as me. Your answer on top and underneath, you would have gotten the opposite. All the signs would have been the opposite. Instead of minus x plus 5, you'd get positive x minus 5. And underneath, you'd get positive 2 plus positive x. All the signs would have become the opposite. This or this would have been correct. I know they look different, but mathematically, they would have been the same. So we have just found the inverse of h, and that's the end of that particular question. I'll be using the blue answer, right? When you finish taking down everything, just raise your hands, so I'll know if to move on or not. Go. Now, check this question. The examiner has asked us to find H inverse 2. Now, tell me something. Forget this question for the time being. Let me just cross that out. If I had asked you to find this question, H2, how much of you all could do that question? H2, just regular boring H2s. One of the first. So here what? Everyone find H2 for me. That was one of the first questions we ever did when we started functions. H, regular boring H2. Just send that answer on the chat for me. Right? The H2, you notice the 2 is in brackets. This is the regular boring questions where you work backwards. So you're going to take 2 and work backwards. So where are we going to put 2 again? Into H, regular boring H. This is our H, regular boring H equation. All they're asking us to do is go to this equation and any x's you see, right? Let me just write it back here. The full equation is 2x plus 5 divided by 1 minus 4x. This 2 means you go to the equation and anywhere you see x, look at x here. Look at x here. You replace it with whatever is in the brackets. But make sure and put it in brackets, right? When you're replacing something in maths, put it in brackets, eh? And all we have to do is work this out. 2 by 2 is 4. 4 plus 5 is 9. 4 by 2 is 8. 1 minus 8 is minus 7. You can, for the time being, let's just leave the answer as a fraction, right? So the answer is minus 9 over 7. If you want to put it as minus 1 and 2/7, feel free. But this is not the point of today's question. This is just me using this question as an excuse to revise something we did about 3 weeks ago, right? But this question is easy because they're asking us to put 2 into H. And what makes it so easy is that we have H. So we know exactly where to put 2. But look at the new question here. Z. These two questions are different, This is H inverse 2. So we still work it the same way. We have to put 2 into what? Not H, but H inverse. Do we have H inverse? I know we have regular boring H. But in the last question, didn't we find H inverse? We worked really hard to figure out H inverse was minus x plus 5 minus 2 minus 4x. And we worked real hard to figure that out. So can we do this question now? Yes. H inverse 2 means we're going to take 2 and visit H inverse, which we do have. And you have to replace all the x's you see with what? 2. You all can more than do the question now. And the examiner will be that nicer. He will make you find H inverse first in part A. And then using the answer in part A, he will ask you to do something with it in part B. Which I find most of the times the examiners are nice. Well, they're not nice all the time. But in this question, that they're usually nice. Right? So let's replace all the x's here. Erase this x, erase this x. And we're replacing it with whatever is in the brackets, which is 2. So part 2 here, part 2 here. Let's see where people are going wrong. Minus 2 plus 5, that's 3. I'm pretty sure. 4 by 2 is 8, so you end up with minus 8. Minus 2 is minus 10. The answer is minus 3/10, or I know some of you will want to put it as a decimal. Both are correct, right? I really don't care if it's a fraction or a decimal. It's your choice. Right? Look for your mistakes. Most people are just adding and subtracting wrong. Like the positive and negative numbers is still getting to you, right? Minus 2 minus 8 is minus 10x. Some people wanted me to say it back, not a problem. When they ask you to find if something is undefined, it will always be referring to a function with a top and an underneath part, a top and an underneath part. The instructions are, and I have the note here, you always put the denominator, which is 1 minus 4x, look at I have it here, and you always put it equal to 0, and you solve for x. The only problem people are having from this point is solving for x. You're trying to get x on one side and everyone else on the other side. The first person you're going to throw across is positive 1. When you throw across positive 1, you're going to get what? When you throw across positive 1, you're going to get minus 1. The next person to throw across is the minus 4. But remember, this minus 4 is touching the x. He's a secret multiply. When you throw across a multiply, you get what? A divide, but the sign, as I mentioned over and over and over last week, the sign will not change when you throw across a multiply. When you divide 2 minus, you will get a positive. So the final answer is positive a quarter, or some of you all want to put the decimal, not a problem. All right, so you have the note to go with it, right? Take down the correct working. The only thing I'll be moving kind of fast with, guys, is how to solve for x, because we passed that bridge a long time ago. So when it comes to solving for x, I have to assume that everyone, you did the homework, and we could stop slowing down class when it comes to solving for x. All right, let's go. But before we do, on to more important things.
The captives whisper in despair. Every full red moon, a terrible creature comes to feed. Soon, it will return again. They speak of a monstrous serpent, 50 feet long, scales burning orange and blue like fire, with glowing eyes that pierce the night. Dark Amun's creation.
So it seems that the monks are working for Dark Amun, and apparently they have this snake, this monstrous snake or something like that. Let's see how this turns out. And apparently it will come in the next red moon. Poor Freya can't get a break.
On the night of the full red moon, the monks extinguish every candle and retreat into the safety of their cellar, leaving the captives abandoned in the courtyard. Terror fills the air as a monstrous serpent slithers near, its hiss echoing in the dark, flames flickering across its fiery skin. Yet Freya, the smallest among them, shows no fear. She has already looked death in the eye.
All right, things are looking too good there. All right, now you don't need graph paper. Before you start to freak out, you don't need graph paper. To be honest, if you have graph paper, fine. If not, all you have to do is draw a y and an x-axis. Make sure the x-axis goes up to 8 minus 3 or whatnot. In fact, you guys don't even have to draw it right now. For those who want to watch it now and just watch me do all the calculations, and then for homework, you review the video, and then you take your time to draw up the graphs, you're also welcome to do that, okay? So when it comes to maths and graphs, there are 2 types of graphs you can bounce up. When you draw a graph, it could either be a straight line or it could be a curve. Think about it. Are there any other types of graphs you can imagine other than a straight line or a curve? Not really. That's the only 2 categories of graphs, well, as far as I know, in the universe, okay? Luckily for you, we're doing the easy types of graphs, straight lines. Now, a fancy word for straight lines is linear functions. It's the same exact thing as straight lines. Don't let nobody mess with your head. So the first thing we're going to do, we're going to draw a function. We're going to draw fx is equal to 2x plus 3. Now, here's the thing. Whenever you're given a graph to draw, remember I said it's only two possible shapes you could ever get, a straight line or a curve. Did you know that you could watch the equation and guess 99% of the times if you're going to get a straight line or a curve? Here's how it is known. If the equation only has simple things like x, once it only has simple things like x and just some numbers, you're 99% sure you're going to get a straight line. Well, 99.99999% sure. The minute you start to see fancy things like x squared or x to the power 3 or square root of x, or if the x is underneath a number. You notice this x here is not underneath the 2, right? If the x is underneath a number, any of these situations will give you a curve. So tell me something, guys. When I ask you to draw this, will I get a straight line or a curve? From just looking at the equation. And we're obviously going to get a straight line because it has nothing fancy in it. No squared, no square root, no cube, straight line. Also, I know most of you all, when the examiner asks you to draw a straight line, instead of fx, they will have the letter y. They will put y is equal to 2x plus 3. Fx and y, or gx and y, and hx and y is the same basic thing. The reason I have to point this out, some teachers, instead of writing y, they will use fx. And you know what happens when you change a slight thing about a math question, even though it means the same thing? It is freak people out. So let's go ahead. Let me show you how to draw this equation. Everyone take down this equation, right? Fx is equal to 2x plus 3. And you could circle the fx and put the letter y. So you can keep in the back of your head that y and fx is the same thing. And then I want you to draw this table for me. Let's draw this table, take down the same exact things, x and fx and whatnot. Take a half a minute for that. To draw a graph, well, a straight line, you only need 2 points. But your teacher will tell you, get 3 points. You will need some x coordinates and some y coordinates. Now, I'm going to make the assumption that everyone here started the homework. Now, I assigned the statistics homework with histograms and graphs and whatnot last week. So the homework would have shown you how to plot points on a graph. So that's going to be my stepping block today. I'm going to assume that. The x coordinates, when it comes to a straight line, you notice that I gave you the x coordinates. I told you in the question, x is -1, +1, and 2. Normally in the exam, for a straight line, they don't give you the x coordinates. You have to choose the x coordinates. Now, hear the confusion. It seems that I just gave you the power to choose the x coordinates. So in the CSEC exam, it have like 10,000 people writing the exam, right? If you are allowed to choose the x coordinates at the beginning of the question, and everybody is going to choose 3 different x coordinates, somebody in Jamaica might choose 3, 8, and 5. Somebody in St. Vincent might choose 100, 5, and 3. So, but here's the cool thing. Even if you choose 3 different values to somebody else, when you draw the graph, it is look exactly the same. It's like magic, right? Boring magic, but still magic. But I will give you some advice, because even though you're allowed to choose anything in the world, you had to be reasonable. Everyone look at my x. Look at my x-axis. Look at it. My x-axis, the examiner is supposed to draw the graph for you. He's supposed to give you a blank graph like this, and already have the 1, 2, 3 and everything labeled on it, he's supposed to give it that in the exam. Now look at my x-axis. Doesn't it start at -3 and go all the way to +8? So if my x-axis goes from -3 to +8, shouldn't I choose values between -3 and 8? So it will fit on my graph? Isn't that common sense? You're not going to choose 11 or 12. If I choose 11 or 12, how is it going to fit on my graph paper? So I use my common sense and I said, hey, my graph going from -3 to 8, I'm going to choose -1, 1, and 2, because I know -1, 1, and 2 could fit on my x-axis. Common sense, okay? Now, here's the thing. After you choose your x coordinates wisely, you have to calculate your y. Sorry, I think I said it wrong there. After you choose your x coordinates wisely, you need to calculate your y or fx coordinates. Let me show you how to calculate the first one. And once I show you the first one, it will make real sense. To calculate this y coordinate, better known as fx, all you have to do is go to the equation and replace x with the current value. How much is x right now? -1. Go to the equation, replace x with -1 and work it out. 2 by -1 is -2 plus 3. -2 plus 3 is +1. Finished. So when x is -1, the corresponding y or fx value is +1. You think you all can repeat the procedure for me? You think you can calculate this value of y here, and then after calculate this value of y? All you're doing is going to the same equation, and instead of replacing it with -1, you're replacing it with +1, and then you're replacing it with +2. So you're repeating the procedure with a different number. So you get to choose, I'm gonna put this, you get to choose the x coordinates, but unfortunately, you have to calculate the y coordinates based on your chosen values. See if you can finish it off. Good news, which is good news. So I'll color code it so we don't get confused. We go into the same equation, and instead of replacing x with -1, we replace x with 1 in brackets. 2 by 1 is 2, plus 3 is 5. For the blue one, go to the same equation, replace x with 2. Notice I'm replacing it in brackets. I ain't taking no chances. 2 by 2 is 4, plus 3, bam, 7. Plenty correct answers. And it seems a lot of people are grasping the concept. And we almost done there now, guys. We almost done there. All we have to do now is plot the points on the graph paper. All points consist of an x coordinate and a corresponding y coordinate. So this is my first point here. -1, 1. -1 on the x and 1 on the y. I'll do it slowly, don't worry. We go to -1 on the x, and then we go up to +1 on the y. That's this point here. I'll write it. -1, 1. The next point is 1, 5. When x is 1, the corresponding y coordinate is 5. 1 on the x, go up to 5 on the y. This is 1, 5. And the last point is 2, 7. When x is 2, the corresponding y coordinate is 7. 2, and we go up to where? 7. And when we join this, we're going to get a straight line. Oh, we got a different color. Get red. Look at this. If we join all 3 points, we get a perfect straight line. Well, it's hard for me to draw. I don't have a ruler. Now, here's what you need to know, guys. You see, when you connect all 3 points, you cannot stop there. You need a long ruler. Using a long ruler, continue the pattern and go to the end of the paper. And the same thing below here. Your teacher will want that. When you draw the straight line, whatever straight line you get, continue it till you reach the end of the graph paper. And the same thing for the bottom part. Continue the straight line until it reaches the end of the paper. And yes, in the exam, the points, you have to put the information next to it. You say, oh, I'll write the information next to the points. You have to do that to get full marks. And look at it there, guys. That's your first straight line. You have just drawn your first linear function. Is it okay to choose x as 0? Yes. And if you choose x as 0 today, I'm just saying, if you replace the x with 0, 2 by 0 is 0, 0 plus 3 is 3. So that means when x is 0, which is here, the y coordinate would be 3. That also falls on the line. If I had drawn it properly, it would have fallen on the line perfectly. And today, when you have a question to do on your own, I'm going to encourage you to always choose 0 as one of the particular numbers. Right? It's a real nice number to always choose. If you want a screenshot, you can. Feel free. Right? Not a problem with me. All right, let's go. Right. Let's investigate this graph. By the way, this is the same exact graph we just did just now, but I use a computer to draw it. You can see it's the same exact thing. Let's do some investigation. Remember, the equation we just drew was y is equal to 2x plus 3. I threw away the fx and I replaced it with y. To be honest, I really hate to see fx. I prefer to see y. It is lower my blood pressure. Whenever you have to draw a straight line, always make sure y is the subject. What do I mean by that? Make sure y is on one side and everyone else on the other side. Once you make y the subject for a straight line, there will always be an x. Look at, have an x here. There will be a number touching the x and a number not touching the x. So the 2 right next to the x, he touching the x. The positive 3, he's separated from the x. All straight lines will look like that once you make y the subject. The person who is touching x, right? I have the note here already. The person who is touching x, you just call them the gradient. So 2 is the gradient. The person not touching x, that's the 3. He has a special name. His name is the y-intercept. The letter used to denote gradient, you might think is the letter G, because if I could go back in time, if I had to choose a letter to represent the word gradient, and you would choose G, but some genius decided to use the letter M. I don't know what people is be thinking, right? I really don't know. The letter M is used to represent the word gradient. And the y-intercept, the letter used to represent that is C. So that is why it is called this topic also, y is equal to mx plus c. M is whoever is touching x, and he represents the word gradient. C is the number not touching x, and he represents the phrase y-intercept. So what's so important about gradient and y-intercept? I'm sure everybody knows the word steepness. If you're climbing a hill, and some hills steep and some hills not steep. Gradient is a way of measuring steepness. The larger the gradient, the steeper the hill. The smaller the gradient, the less steep the hill is. Here's the cool thing. Whenever the gradient is a positive value, the line is always sloped upwards. If the gradient is negative, the line, when you draw it, will always slope downwards. Now, I do in maths a long time, right? So here's the thing. Even before I drew the graph, I knew the graph was going to slope upwards. You know how I knew that? Well, I looked at the equation and realized, hey, who touching x? Positive 2. Positive 2 is my gradient. When something has a positive gradient, when you draw it on a graph, it will always slope upwards. So I was able to predict how my graph would look, the direction it would slope, even before I draw it. And I want you all to be able to do that also. And I also knew, look at your y-axis. Isn't it slicing the y-axis at exactly 3? Look at it. The red line coming down, zoop, 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 and it slices the y-axis at 3. I knew that when I was drawing my graph, I knew beforehand it would slice the y-axis at 3 because my y-intercept was positive 3. So it would slice the y-axis at positive 3. And whenever I give you a graph to draw, I want you to predict how it will look in your head even before you draw it. So when you finally draw it and it matches up to the image in your head, you're going to leave that exam room smiling because you know no way you get that wrong. Okay? I want everyone to take down everything here. Everything I'm circling, take it down. We're going to get a practice. Practice it. Let me know when you finish taking it down. Oh, I think you did a small break there. All right, seems that the serpent has made its way into the cage.
The monster slithered into the courtyard, its massive coils shaking the ground as captives scattered in panic. Some were snatched up and devoured, others crushed beneath its weight and the debris it sent crashing down. Yet Freya did not falter. In the chaos, she rallied the terrified captives, urging them to fight back with whatever they could seize: stones, broken wood, anything at hand. One by one, the captives found their courage. It was fight or die.
All right, so it seems some panic in the cage there.
Unbeknownst to the captives, the red adder had been scouting the area for some time, hunting the beast. Hearing the chaos, he rushed toward the monastery. With fearless resolve, he leapt from a rooftop into the fray, driving his sword with all his strength straight into the monster's skull.
All right, so it seems the red adder has finally met Freya. So that's how they met during this battle, right? All right. So let's work backwards now, right? Let's say somebody now comes to class. And remember that equation I gave you at the beginning of this exercise. You were asked to draw, and this is how it went. You were asked to draw y is equal to 2x plus 3. Let's say I was drinking coffee and some coffee spilled over the equation and the equation disappears. Do you think it's possible for the person who now came to class to get back the equation? What equation gave us this graph? There is a way. All he needs to know is a few things. That the equation of any straight line is y is equal to mx plus c. All straight lines follow that general format. And all he needs to do is calculate the gradient m and calculate C. That's all he needs to do, you know. So once we give him the formulas on how to calculate M and C, he should be good. I know different teachers have a different method of getting M and C. You ask 3 different teachers and have 3 different methods. I would prefer if you all use this method. We will always try to find the gradient first. Always, right? Oops. That's 1 second there. We will always try to find the gradient first. And we will try to find C second. Right? Just take down what I take down here. Take down what I just wrote here. Put this as first. We're always going to find M first, and we're always going to find C second. Always. Right? Always do it like that. M is for gradient. I'm going to put the symbol here in case you all forgot. The symbol for gradient is the letter M, because some genius thought that was a great idea. To find gradient, you just need to memorize this formula. Some of you all know it already. y2 minus y1 divided by x2 minus x1. Now let's go and write back the formula here, right? To find gradient, we're going to use y2 minus y1 divided by x2 minus x1. This is not y squared. Squared, the number would be here. That's y2. The 2 is small and underneath. So you must be asking, well, where are we going to get y2 and y1 and whatnot? All you have to do is choose any 2 points on the line. Hear that phrase again, huh? You need to choose 2 points on the line, any 2 points, which means, once again, for CXC, if you have 10,000 people writing the exam, and everybody going to choose 2 different points on the straight line, the magic is, even if I choose 2 different points to you, I will get the same answer. So here's what. I'm going to choose these 2 points to make life simple. And I want you all to choose the same 2 points. This point, I'm going to call it point A, and I'm going to choose this point here. I'm going to call it point B. According to my first point, point A, that I chose, how much is the x coordinate? 1. And how much is the y coordinate? 5. 1, 5. And according to point B, the second point I chose, how much is the x coordinate? 2. And how much is the y coordinate? 7. You must, well, when you're stating the value of a coordinate, you have to put the x before the y. X always before y. So where does the x1 and y1 and the 2 and the 1 come from? It's really simple. It have 2 points in front of us. Choose any point first. Close your eyes and choose A or B first. It doesn't really matter. But I'd like to go in alphabetical order, right? I'm going to choose A first. So according to point A, because I choose A first, doesn't A have an X and a Y coordinate? Because I'm choosing A first, everybody in A will have the subscript 1. So I call it X1 and Y1, choosing everything in that A point first. By default, I have to choose B second now. B also has an X and a Y. Call it X2 and Y2 because you're choosing everyone there second. And all we have to do now is throw it into the formula. Now, I want to point out something about this formula. This question pretty easy. It have no tricks in it. You notice the formula to calculate gradient. When you buy it, it comes with 2 free minus signs. It have a minus sign on top and a minus sign underneath. So when you buy it, it comes with that. Be careful. Sometimes 2 minus signs will end up touching, and by now everybody knows in this class. If 2 minus signs touch, you just get what? A positive. It won't happen all the time, but it will happen sometimes. So let's substitute in the values. I'm going to put in a 2 minus sign, so I don't forget them. How much is y2? y2 is 7. The formula comes with a 3 minus sign. How much is y1? y1 is 5. How much is x2? x2 is 2. How much is x1? 1. Let's work this out. 7 minus 5 is 2. 2 minus 1 is 1. 2 divided by 1 is 2. Look back in your notes. Any gradient was 2. Remember when I first put this question, over here, the gradient was 2. Look, we got back to 2. The person who just came to class late, he's able to calculate back to 2. So this is what he knows so far. The person who just came to class late. The equation of any straight line is y is equal to mx plus c. He has just worked backwards to figure out m. He's going to erase m and put what in its place? 2. So take down up to there. He has just figured out piece of the puzzle that m is 2. We just need to figure out, well, not we, he needs to figure out the value of c. Right. And I have the instructions on how to find c there. You'll see it in pink, right? To find c, once you have the gradient, we have the gradient, choose any point on a line and substitute it into this equation to find c. Let me make that simpler for you. Remember, we always find the gradient first. We just use this formula to find the gradient. So we replace the gradient of m with 2. To find c, choose any one of the 2 points you have. You could choose any point on the line, but we have 2 here. You could choose A or you could choose B. Doesn't matter. I'm going to choose B just for fun. According to point B, x is 2 and y is 7 at that particular point in time. So let's go to the equation. According to my chosen point, y is how much? 2. Sorry, y is 7. I'm going to replace Mr. Y with 7. And how much is x? At the same time, 2. Look at it. I replace that x with 2. Now I can simply solve for c. 2 by 2 is 4 plus c. To solve for c, I just need c on one side. C is already on this side. Throw across positive 4, you get what? Minus 4. Ta-da! C is 3. And I can erase c with 3 now. Isn't that the equation we had on the slide before? Look at it. The student was able to backtrack to get the equation from only seeing the graph. He just worked backwards. He knows the equation now is y is equal to 2x plus 3. Some people will ask the question, is it okay to choose A? Yeah, you could have choose A. If you chose A, you would have to replace the y with 5 and the x with what? 1. And when you work out C, you would have still get 3. Also, some people are saying, for this question, I didn't need to work out y is 3. There was an easier way. Isn't C the y-intercept? Isn't the y-intercept where it slices the y-axis? So instead of me doing all of this calculation, right, I could have just watched my graph and say, hey, the y-intercept is where the red line slices the y-axis. It's how much? 3. I would have gotten 3 anyway. In a case like this, because we could physically see the line slicing the y-axis at 3, the examiner will not care if you look at where it slices the y-axis or whether you do the full calculation. Either way, you're getting the same amount of marks, right? So some people are probably asking, but why still make me work it out if I could just watch the graph? Sometimes in the exam, they don't give you the full graph, right? Sometimes in the exam, they only give you a portion of the graph like this. If I erase all of this, right? Let me say the examiner bring the question exactly looking like that. will you be able now to see where it slices the y-axis? You will not. You will be forced to do it the long way via the calculations. Don't worry, I'm going to prepare for all the eventualities here, or all the ways it could come. All right. Right. Well, we did this already, right? All right. You think you all could do this one for me? Let's draw back a graph. We're going to do back the whole thing now. We're going to start fresh. Let's say the examiner gives you this graph paper. It already have the y and x axis. And he wants you to draw this graph. What's the first thing we have to do? Remember, we have to choose our values for x. We have to choose 3 values for x. Just to refresh your memory. Everyone in the Caribbean is going to have to choose 3 values, and most likely we're not going to choose the same exact 3 values, but we have to use common sense. Our x-axis goes from -3 to +8. So let's all agree on a class. Let me just choose the same values. Let us choose -2. I always love choosing 0. And let's choose 5. Let's say in the exam, you chose -2, 0, and 5. I want you all to calculate the corresponding y values. Take a couple minutes and send the answers. Most likely, we're going to run into problems. I hope we run into our problems so I can teach you all something from it. Let's see. Use a different color for each one. For this one here, we're supposed to replace the x with -2, right? -3 by -2 plus 6. 3 by 2 is 6. 2 minus make a positive, so it's +6 plus 6. 12. Let's check in through my answers here. The first one's supposed to be 12, right? Next one. 0. -3. 0 plus 6. All I did was replace the x with 0. Anything by 0 is 0. 0 plus 6 is 6. All right. Last one, I use pink. -3 by 5 plus 6. -15 plus 6. I can't do that in my head for some reason at this point in time, so I use my calculator. I got -9. Do you all see the problem here? Anybody? I mean, all my calculations correct, right? Anybody sees the problem? Look at it. The first point, -212. -2. But 12 cannot fit on the graph paper the examiner gave me. 12 is too large. It cannot fit. You have a little problem there, right? My calculations are correct. It just cannot fit. What about the last point? 5, we can't even make it past -2. We have to go all the way down to -9. This is a common problem in the exam. The x values you choose, perfectly good. It's just that when you calculate, right? Well, when it's time to calculate, when it's time to fit the y value now, it cannot fit. So the x good is just the y. So what do you do in a case like that? You choose x values, but the y values can't fit. Obviously, you don't get up and walk out the exam. You pull up your socks and say, hey, we have to choose some other values. It's just as simple as that. It happens to everybody. The only legit value is the 0. So it's a little trial and error. So how about we choose -1 and we choose 2. See if the -1 and 2 now give you some answers that could fit on the graph paper. minus 3, x is minus 1 plus 6. I don't think this one fits in either. Minus, they get positive 3 plus 6, which is 9. 9 cannot fit on the y-axis. That is okay. Like I said, it's going to happen to everybody. Well, at least let the 2 work. Let me see if the 2 working. Minus 3, 2, and 6. Minus 3 by 2 is minus 6. You're going to get 0. All right. So we get 2 of them to fit. It's just this guy. Let me try 1. Instead of minus 1, let me try positive 1. I'll do it quickly for you. Right? Minus 3, 1 plus 6. Minus 3 plus 6, you'll get 3. I think now everything could fit. And you will waste a little bit of time in the exam, right? Trying to negotiate values that could fit on the graph, I guess. I guess that's a nice way of saying it. Now, before I even draw this graph, let's do some predictions. Will this graph slope upwards or will it slope downwards? From just looking at the equation, fx is minus 3x plus 6. Before I even plot those points, will it slope upwards or will it slope downwards? Right, people are getting it correct. It's going to slope downwards. Look at it. Any value touching x is minus 3. Isn't he the gradient? Whoever is touching x is your gradient. Your gradient today is negative 3. It's going to slope downwards. Also, who is not touching the x? Any positive 6? So I bet you this graph will slice the y-axis at 6. Let me plot the points. The first point is 1, 3. 1 on the x, 3 on the y. Next point, 0, 6. 0 on the x, 6 on the y. Last point, 2 on the x, 0 on the y. Let me put any points here. 2, 0, 1, 3, 0, 6. Look at it. If I connect this, oops, that's a terrible color. If I connect this, the graph is sloping how? Downwards. And if I continue this graph, like continue the pattern like this, which I'm supposed to do, you notice it not only sloping downwards, but it's slicing the y-axis at 6, exactly on 6. So when I leave the exam, I don't have to ask anybody or ask my friends if I get what them get. I know I get it correct because my prediction was it would have sloped downwards and cut at the 6. So I don't need to ask my friends what them get in the exam. I left the exam room confident. Right? If you want a screenshot, you can screenshot. It's okay. Right? If you want to draw the graph later in your books, not a problem. Right? Ah, zoom a little.
Darkamun's creature lay dead and still upon the courtyard stones. Some peasants cried out in triumph, while others wept for those lost in the struggle. Then a heavy silence fell. Without a word, the captives turned as one and marched into the monastery. The monks scattered, some fleeing in terror, others dropping to their knees, begging for mercy. One by one, the monks were dragged into the cold, stone cells beneath the monastery and locked away. The captives sealed the heavy doors, shutting them forever. As they departed, the air echoed with the monks' desperate pleas for mercy, their voices fading into silence with each step away.
All right, so I guess, I don't know if you all agree with that ending. Maybe the monks deserved it. Maybe they didn't deserve it. Who knows? All right. Right. So you think we could work backwards to get back the original function? Well, what do you guys think? Let's say Bob now comes to class, somebody called Bob, right? And we throw coffee on the screen and we erase the original equation. Remember, this is the graph we just drew. I want you all to help Bob get back the original equation. Take 3 minutes. Work back and see if you can get back that 3, that -3, and that 6. Just to put on -3 and 6, work it backwards and show yourself, show Bob, don't let Bob down. You can get that -3 and 6. Don't do it for yourself, do it for Bob. The first thing you want to do is calculate the gradient. Remember, the gradient, the equation of any straight line is y is equal to mx plus c. You trying to calculate the gradient first, and then you see about the y-intercept second. So you have a formula for the gradient, right? I'll use this space here. You could choose any 2 points, but choose 2 convenient points, right? To me, this is a nice convenient point. It on a cross section. So this is point A. He could be 1, 3. Where's another? Oh, this point seems to be all right. 2, B, 2, 0. Now remember, any 2 points you choose, you're gonna get the same answer for the gradient, right? I choose in those 2. Obviously, I won't be able to satisfy everybody's points, right? Because everybody's going to choose 2 different points. Because I choose A first, I'm calling this X1 and Y1. And if I choose in B second, he's going to be X2 and Y2. Let me throw him into the formula here. Y2. Y2 is 0 minus Y1 is 3. Look at that, Y2 and Y1. X2 is 2 minus X1 is 1. 0 minus 3 is -3. 2 minus 1 is 1. Look at there. -3 divided by 1 is -3. We have just figured out or worked backwards to figure out your gradient is -3. And I chose these 2 points. If you choose any other 2 points, you're going to get -3. I guarantee you. Okay? Not 3, guys. -3. That minus sign is real important. Okay? Now, to find the gradient, sorry, the y-intercept, I know some people will have just used the shortcut because we have the whole graph. We see it slicing the y-axis at 6. So that means C is 6. But let me just say, Bob was drinking his coffee and he spilled coffee all over here. Blah. So now Bob can't even see where it cut in the y-axis. How will he get back the value? He could choose any one of these 2 points, A or B. Let's say he chooses A. According to point A, y is 3 and x is 1. Now, I'm just saying, if he chose point B, he will get the same value for C. But I'm going with A. According to point A, y is 3. That's why I'm replacing the y with 3. The gradient is -3. And x at the same point is 1. -3 by 1 is -3. Solve for C, throw across -3, bam, +3. We get back 6. C is 6, +6. Right? Don't worry, I won't bore you with this. So this is the last slide that we'll be doing today. Let's see how it ends up.
The Red Adder, realizing that Freya shared his goal of destroying Darkamun, chose to travel with her and vowed to train her in the art of battle. Together they ventured across the land, facing many trials. On one such journey, they discovered an ancient cave where a great battle had once raged. Among the remnants, Freya found the armor she desperately needed and claimed it as her own.
All right, so that's the end of the story, guys. Next week, we'll be doing the story of Dalko. He was the kind of dragon warrior. So, guys, good luck with the homework and see you all next week. All right, have a good night and thanks for taking part in class. Take care all.